There we go. See, it's even in a different location now. Before it was over here, it was all confused, didn't know where its home was. Seriously. Oh, did you guys all see Guardians of the Galaxy?
Yeah.
Who's your favorite character? There's only one correct answer.
Groot.
Groot is the correct answer. I love that guy.
I am Groot.
I am Groot. It's like, I know they're ungrateful. You know that was the voice of Vin Diesel?
Yeah.
That doesn't make any sense to me. Why would they pay like a high-paid actor
Probably didn't do it for that much money.
to be the voice of a tree guy that whose all his lines are "I am Groot." We are Groot. But that was only once. So if he had
Spoilers.
So if he had like 70 lines during the movie, 69, I picked that one for very specific reasons, where Christian University, get your head out of the gutter, people. It's a different reason.
Care to share
What-
another reason?
Not with the recording going.
Actually good? Yeah. Oh,
Yeah, no, we're cooking. We're good. Yeah, so I thought that. Did anybody see Teenage Mutant Ninja Turtles? Was it any good?
Yeah.
Really?
I thought it was pretty good.
Well, actually, you kind of have bad taste. So, anybody else see it? Do they have movie theaters in the Amish communities, or do you guys just kind of act it out?
Just kind of act out.
Jebediah was Donatello. What's this?
With real explosions.
Really? Just throw like flaming hay bales. All right. So this is CSC350 operating systems. This is all up on Angel. You can read through this crap. Click. There we go. Prerequisite for this class. CSC300, which is data structures, the second, well, really the third programming class, right? If you have not had that class, I'm not going to kick you out, but there's going to be programming in here, and the programming is going to assume that you've had this class. So if you haven't had the class, then you're going to have to play catch up or cry more. So that's the scoop. So, this class will probably be half theory, half programming, because we're going to talk a lot about different operating systems theory components, and then we're going to experience them through writing our own little simulator, operating system simulator, for different aspects of the operating system. Cool? Blah, blah, blah. Normal grading scale, 90, 80, 70, 60, dealio. 45% of your grade will be homework assignments. 15% are quizzes. Most quizzes will not be announced. It's kind of my way of taking attendance. Although I'm actually working on I'm working on a project for actually another thing I'm working on, where I might do attendance automated through an RFID reader, so that all you will use your student ID cards when you come in. That's how you'll do your attendance. You just go by the RFID thing. So yeah.
So we just give our IDs to one person and scan them all?
Well, you can, but then you're also potentially giving them meal swipes.
Meal swipes, I'm good.
So you can think about it. But quizzes will generally be pop quizzes. I tend to give them when there are many people missing from class, but sometimes I just tend to give them when I feel like it. There will be 2 tests in here, midterm and final, each 20% of your grade. As usual, I'm not a big believer in one bad day screwing your entire grade for the semester. So if you come in, you bomb the midterm, that at least gives you an idea where you are in the class. I'll probably work something out with you to count your final twice or something like that, or at least give you something in the middle. So, if you get a 3 on the midterm, your grade is recoverable. Okay? So I try to make my classes relatively low stress, but I want you to learn a lot. I want you to participate. I want you to be here. I don't want you to stress out, because I think you'll learn better when you're having fun rather than all this other crap. But you still got to do your part. Blah, blah, blah. All right. Questions about any of that crap? Okay. There isn't an official text for the class, but if you did want to get a book, I'm going to be using as the core component of the class the slide set for something called it's called the dinosaur book. So
your son flips in it?
It does. So it's probably in the 14th version or something like that right now. Where's the latest one that came out? Here's the 2013. Is that the newest? Does this give a version number? Oh, this is the second edition of that, so that must be a new. They must have just tried to make more money and they ran out of characters for their other versions. In any case, it's kind of the de facto operating systems book. So if you wanted to pick up a book, if you're a hardcover book person and have a bookshelf somewhere, I would go on to eBay and buy one of the older editions for $15 or something like that. I think the slides that I'm using is from the 8th edition or something like that. Doesn't really matter. Most of the stuff we're going to do, I'm going to use the slide set and then I'm going to deviate from it. I'm going to augment it and other crap like that. But if you're a collector of books, this would be a good book. You won't need it. Everything you're going to need I'll cover in the lectures, and I record all my lectures and upload it to YouTube, so it's a good way to put yourself to sleep at night, that kind of stuff.
Watching ads.
Huh?
Watching ads on your YouTube.
That's right. Click. Lots of clicks. Major bucks. Made like 31 cents last semester. And we're probably all from her. What was I talking about? Oh, so no required text, but if you'd like to get the text, that's the supporting thing. And that is the de facto operating systems book. If you go on to grad school or something like that, chances are they'll use that book. And it's called the dinosaur book because, as you see, every single one of their books has dinosaurs on the cover. Okay? Questions about that? All right, so let's dive in then. I didn't write these slides, so if they suck, then it's on them. I'll add stuff to it that won't suck, I promise. And they all have dinosaurs on them. See this? Why can't I click that dinosaur? It's just the whole back. That sucks. Okay, so here, before you look at that. So what is it? What is an operating system to you? When you hear operating system, what does that mean to you? We all kind of have a concept to some level in our heads, but what is it? What is it actually? What do you say an operating system is? And then I'm going to follow that up with why do we need them? Not a rhetorical question. Answer. Somebody answer. Yes. Tim.
Basic platform to run computers on.
Basic platform to run computers on.
Or run programs in.
Okay, and why do we need it?
It provides a it gives kind of a standard so that when you make your programs, you kind of make it so that it can work with the operating system, so then you can put them all onto the same machine and it'll work.
Okay. What did our first computers look like? So when you took the 150 class or 175, well, I don't know which one they show the pictures in. You talk about UNIVAC and EDVAC and the big gymnasium computers. What do they look like, and how did you use those? You all had 150, right?
Yeah.
Did you talk about UNIVAC and stuff like that? 150.
Yeah.
You probably showed a picture, old black and white.
They were like rooms.
Okay, size of a room, and how did you interact? Go ahead.
Terminal.
Yeah, that was going to be a pretty late version, but I'm okay with that. So some of the as computers got to like the size of a refrigerator, and then maybe we had terminals that we sat at, and we'll come back to that.
Punch cards.
Well, that punch cards are probably even later than that. That was the way that people could actually write software and then run them on the computer instead of having to sit there in front of it. So if you had taken the equivalent of like the 250 or the 300 class 20 years ago, 30 years ago, when you wrote your computer, when you wrote your program, you would actually write it with cards with punch holes in them, and then you go wait in line in a lab somewhere for your turn to run your program on the computer. So somebody would load these things in there and push play, and it would feed your cards in there. Then you'd get the output and find out if it was the right. And then when you screwed up your program because you suck, you had to go back and rewrite it. So every single time right now when you use Eclipse and you hit play, the little play button, that was going and waiting in line and handing them a stack of cards. When did computers go from being the size of gymnasium to the size of, that we have our computers today? What was the major turning point in technology that allowed our computers to get so much smaller? Of course, the answer is the fall of the Amish space program. It's kind of our fall guy for everything.
You're standing next to the fire. We need smaller computers.
Transistors. What did we have before transistors? We had vacuum tubes, giant light bulb looking things, right? And how did people interact with computers back when you had UNIVAC that had all these vacuum tubes on it? They would turn tubes on and off. Screw light bulbs in, unscrew light bulbs to set inputs, right? So you might have 8 rows of inputs, and each row maybe has, let's say it's a byte. So that byte was represented by 8 vacuum tubes. So the number 1 would be 000000001. So that would be 7 light bulbs turned off, 1 light bulb turned on. That's how you put that input in. Make sense? That's how we interfaced with the hardware back then. We directly interfaced with the hardware. Now, that maybe made some sense because light bulbs are big enough, right? But as soon as we started demanding more power and more flexibility from our computers, let's take one of these initial computers that are the size of the gymnasium. What if you had an input bigger? We'll just make the assumption that it limited the size of the input to a byte, per variable or something. What if you needed to put in 16 bytes? Well, you kind of had to work with the tools that were in your toolbox. You can kind of bridge those across 2 inputs and somehow do the math to make it work. But you didn't have the ability to say, oh, we're going to use a 16-byte input now because your inputs were hardware-based, right? Well, so one of the weaknesses of our early computers, besides their size, was how we interfaced with them. Then comes the rise of the operating system. Operating system is a piece of software that lives between us, the user, and the scary hardware, whether it's the giant gymnasium with vacuum tubes or the tiny, tiny, tiny motherboard that's 1,000,000 times faster than that gymnasium filled with vacuum tubes sitting inside of this laptop. Okay, I'm not sitting here touching, 2 wires together on the motherboard and hoping that I got it right. Okay, that's not how human beings interact with computers anymore. We interact with computers through these operating systems. Make sense? So, a program that acts as an intermediary between a user of a computer and the computer hardware. Operating systems goals: execute user programs and make solving user problems easier. That is, instead of us having to put our inputs in through vacuum tubes and crap, we get to write programs. As computer science people, we get to write programs and define variables and say the math to do. Then we run that program, and behind the scenes, magically, the operating system translates our requests into instructions that the CPU understands. Right? And what's the CPU? If you had to tell me what a CPU is, we're going to ask that question again when we talk about CPU scheduling in here, but what is a CPU? Brain of the computer, okay. What does the brain of the computer do? Can your computer work without a CPU? Does a computer need a brain? I mean, Abe seems to get by just fine. So what does the CPU do?
Does it operate, do the instructions, execute the instructions?
Okay. So a CPU has a collection of magic tricks. That's how I usually refer to them. Collection of instructions, things it knows how to do. And they're usually very kind of small little movements. Move value from this hardware register over to this hardware register. Why? I don't know. It just fits into the bigger puzzle. If I move it from here to here, and then from here to here, and from here to here, and then I do this, this, and this, and this, all of a sudden, bright, pretty pictures show up on the screen. Woot, right? Okay, so that's what the CPU does, is it has a bunch of magic tricks, and if we tell it to do these tricks in a certain order, good stuff comes out of it, okay? So the CPU is kind of our slave. It knows how to do these 500 things. We write our programs. The compiler turns our programs into the lists of how the order in which those instructions need to happen, and then we just give our CPU those instructions, and it goes to work. So without the CPU, we don't have a computer. Really, the CPU is the computer. The motherboard, the thing that looks like it has all the wires, that's the thing that kind of connects all the pieces of our computer together. The CPU, the memory, the keyboard, your peripherals, your USB, stuff like that, the screen, all the crap that makes up the whole computing experience are all held together by this motherboard, but ultimately the problem solving is done by some CPU, whether it's our central processing unit or the graphics processor, the GPU that's on your graphics card. A lot of stuff is done on that as well. Okay, so one of the goals of an operating system is to execute user programs that make solving problems easier. Make the computer system convenient to use. So how many of you use your computer all the time? Whether it's playing games or, I'm sure most of the time you're using it for productivity, right? How many of you would use your computer that often if you were messing around with vacuum tubes? Like, what if that was the Diablo 3 experience?
Well, to be fair, when it started, that's kind of what it was.
What's up?
When the game started, that's kind of what it was.
When Diablo 3 started, when games in general started?
Diablo 3.
Really? I didn't think it was that bad.
Oh, it was awful. You couldn't play the game for like 2 weeks.
Well, I didn't have any problem. I got it the day it came out.
And you never had any problems logging in or anything else? The first one, not the expansion.
Yeah, I didn't have any problems. I played it on a Mac. Maybe the
No, the servers were just down.
Yeah. Battle.net was down.
Everything.
Well, I mean, their login server is Battle.net. So.
Yeah, that's why people were complaining about.
Maybe I did, and I just forgot. But I don't remember ever having a problem.
Because Battle.net was offline, and everyone was complaining that there was no offline version of it. So that's why they wanted an offline version.
Oh, I kind of remember that.
Blizzard sucks so much.
Yeah, I kind of remember that. Yeah. Yeah, but I didn't have any problems. So anyways, probably would not have played Diablo 3 or Battlefield or pick your favorite stupid game, right? Probably would not have played these if it was vacuum tube based. Kind of like I remember in the relative early days of World of Warcraft, somebody came up with this because people were getting, it was when the whole obesity epidemic was coming about, people hooked a treadmill up to the World of Warcraft game where your guy his movement was actually controlled by you running or walking on the treadmill. Well, so, I think about it. If I'm playing WoW, if I'm going to go from town to town, I jump on the horse and I go, right? But what if you actually had to walk that distance or run that distance? I wouldn't play that. Amish, that's probably the only way you do play, right? World of Warcraft for you is just you and your buddies. You get out there with swords and stuff. And how do you live without electricity? I just don't get it. What was I talking about? Oh, so use the computer hardware in an efficient manner. So this is one of the things that the operating system does that's kind of unbeknownst to the user, but very important to the user. We want our computers to feel fast, right? Operating system's doing a whole bunch of crap behind the scenes that we're not even aware of. But we just assume it's doing it in the best way. And when it starts crashing or acting buggy, we just blame Microsoft, right? If it's a Mac, we don't complain because we already have so much money invested that it probably just works, but we're poor. All right? So, computer system structure. Computer systems can be divided into 4 high-level components. I maybe subdivide these a little bit. So you have your hardware, provides basic computing resources, the CPU, memory, I/O devices, blah, blah, blah. The operating system controls and coordinates use of hardware among various applications and users. So that's that middleman. Coordinates the hardware, those resources, in terms of the user's demands through their software applications. Application programs define the way in which system resources are used to solve the computing problems of the users. Things like word processors, compilers, web browsers, database systems, video games. And then the users, the actual people using the computing resources. So notice they say people here, but they also have machines and other computers. So with networked-based computers, you have other computers talking to an individual computer, right? So these are all things that kind of go down. So this is what's part of the entire computing experience. Notice the operating system is just one piece of that. So here's us down here, the users. We use application programs. The application programs use the operating system. The operating system talks to the hardware. That's the layers. Okay, so this is kind of what I just said. Users, application programs, talks to the operating system, talks to the hardware. So, visual version of that. I promise I didn't look at that before, so I must sort of know what I'm talking about. Wait, where am I? What time is it? Is this an hour? What time is this class over? 50. Okay, this is Monday. 50-minute classes. Got it. Boom. Look, I'm usually on the golf course at this time, people. Okay, what do operating systems do? Well, users want their computers to be easy to use. So think about what this means to us. Let's roll back about a year when Windows 8 first came out. Big complaint about Windows 8 when people first started getting it. Why didn't people like Windows 8? It's different. It's different. Where's my start button? Okay. Ever since Windows 95, we're used to, well, where do I go to start? You click start. That's how you use the computer, and there's no start button. Does that mean Windows 8 was hard to use? Well, once you learned it, it wasn't bad. But because it was different,
It was still pretty bad.
it's no worse than any of the other ones. It's fast enough to do things. But you had to learn the Windows 8 way of doing it, and people don't like change. Well, if you were used to Windows 95, you could use Windows 98. You could use Windows XP. You could use Windows Vista. You could use Windows 7.
No one uses Vista.
But you could use it. It had the same layout, right? All right. So we need it to be easy to use. Users in general don't care about the resource utilization. They don't care what happens behind the scenes as long as their perception is that they're the most important person using the machine and it's fast. Okay? Shared computers, such as mainframes or mini computers. So mainframes still exist today. We don't really see them very much in general computing, I guess, but they do still exist. IBM is probably the main provider of mainframe computers today, and they're the size of a small fridge. So we're still talking pretty big machines. Like a dorm fridge is about the size of a mainframe now. And even just like 10 years ago, a mainframe might have been the size of a full-size fridge. So shared computers have to keep all the users happy. So there's a difference between operating systems right there. We have single-user operating systems, Windows, the Mac OS. These operating systems, like right now I'm using this operating system, I'm using the Mac OS on this laptop, and the job of this operating system is to make me, a single user, happy. Okay? In a mainframe type situation, or if you have a server somewhere that you're logged into, if you've done, well, here, let's go to our video game example. So we were just talking about Diablo 3, which uses a server in the middle called battle.net for their login authentication system, and it's also the thing that connects all the people playing. If you're a console gamer, Microsoft, or what was it, Xbox Live, or PlayStation Network, those are the same kind of tools. That tool isn't there just to make the person playing the game happy. It's to make all those people playing that game happy, all at the same time. You're playing a first-person shooter, and I'm playing against Amish, and he's getting his request processed more quickly than mine. That's unfair to me, right? Now, if mine were getting processed more quickly, it would not be unfair to him. Yes, I am terrible at first-person shooters. Literally incompetent. It's terrible. It's really bad. So, in any case, those types of computing systems have a job of keeping more than one person happy at a time. So some of the decision-making of the operating system has to change. All right? Users of dedicated systems, such as workstations, have dedicated resources, but frequently use shared resources from servers. So if I'm sitting at this computer, my computer has, well, this one doesn't, but you might have a DVD drive. I might have a mouse, a keyboard. Those are dedicated to me. External hard drive, whatever it is. These are dedicated resources that I'm using. Now, there might also be resources that I'm using external to my machine. If you use Dropbox, for example. How many of you in here do not use Dropbox? How many of you are lying? Literally every person here uses Dropbox. Very impressed. So, right up here, I have my Dropbox, shows that it's synced. And so, even though I might be saving stuff locally on my hard drive, that application program, Dropbox, ensures that anything I stored in my hard drive also gets duplicated up in the cloud, synced. So that's an application program that I'm using all the time, even though I'm not necessarily aware of it. I just trust that it's happening. I monitor it by the check mark, right? But it is running all the time. And as long as I have the little green check mark there before I shut my lid of my laptop, I know the cloud is up to date with what's here in my laptop. Now, that would be a system that is a shared resource. Similarly, Dropbox, being a server somewhere out there, their job isn't just to make me happy. So all of us in here are Dropbox users. So if all of us are saving files on our computers at the same time, you expect Dropbox to be working well for you. And you expect it to be working well for you. It should be working well for all of us at the same time. So it has to solve a different set of problems than just my Mac computer needs to solve in terms of working with me. Handheld computers are resource poor, optimized for usability and battery life. Realistically, it may be becoming less and less true. These guys are becoming more and more like full-fledged computers, but it's still a fair statement. You can still do more with a laptop or a desktop computer than you can with a smartphone, but that gap is narrowing, mostly because of application programs. Right? More and more apps keep coming out that, in some cases, make things more convenient to do on your smartphone than it does sitting in front of your computer. But these guys, their job is to give us a good user experience, easy to use, fast enough for the things that we do with it, and have good battery life. Because these guys aren't tethered to the wall. Right? I mean, right now, I'm, video and audio recording here on this laptop. That takes up processing power, so my battery would be draining relatively quickly. But I've tethered it to the wall. The wall. It used to be over here when I had took away my laptop bag holder. Could have left me a little shelf over there or something. But in any case, these guys have, the operating systems on a mobile device have even a different set of priorities than your desktop. Some computers have little or no user interface, such as embedded computers and devices, automobiles, things like that. So when you get into you first turn your car on. I mean, I know now so a lot of our cars have computers in them with screens and all this crap, but when you get into your car, there's a computer somewhere. that's bringing all the systems up to date, that's telling the air conditioner to turn on, that's enabling the power to your radio, all this other stuff. And the interface for that might be as simple as key turns. That's the on switch, and now everything just happens. Similarly, the interface for increasing the fan speed on your air conditioning in your car is just a single button. That's the entire interface, a little knob, dial. Okay? So computers come in all shapes and forms, so do interfaces. So you want to have an appropriate interface for the type of computing that you're doing. Again, remember, users want convenience, ease of use. Don't care about resource utilization. All right, so whatever the interface is, it has to be easy for them to accomplish what they're trying to accomplish with it. Okay, so operating system definition. OS is a resource allocator. Manages all resources attached to your computer, decides between conflicting requests for efficient and fair resource use. Decent example of this. Let's say that you are currently copying a large file to your hard drive. And then you decide, I want to copy another large file to your hard drive, or to my hard drive. Usually you have some sort of progress indicator. It says, okay, 45 minutes until your, 50 gigabyte transfer is done, right? And now I want to transfer a 200 megabyte file. Big enough that it's not instantaneous, but small enough that it should happen relatively quickly. Well, now the operating system has to make some decisions. Does it finish the first large transfer before it even starts the smaller one? Does it pause the first one and do the second one? Does it do a little of each? What has your experience been when you've seen something like that? What does it seem like the operating system does?
Tried to do it all at once.
Okay, it seems to try to go back and forth, right? So it's giving a little bit of time to this transfer, then a little bit of time to this transfer, then a little bit of time to this transfer. And that's actually probably the most inefficient way of handling it. But it's the best the operating system really can do. And the limitation isn't the operating system, it's the device it's using. A hard drive has a single read-write head. So you can only read or write one thing at a time. Well, I could be writing this file, or I could be writing this file. I can't be writing both files at the same time. And hard drives, specifically mechanical hard drives, we're moving away from this now with some of our solid state drives, but specifically mechanical hard drives, you have to spin to the location on the drive, the location on the disk where you're writing that file. So if you're going to write this one for, let's just keep the numbers easy. We're going to write for 1 second, this file. Then we need to pause that, then spin the disk to get us to the location of the other file. Then we're going to write that for 1 second. Then we're going to pause, and we're going to spin the disk to the other one. 1 second, pause, spin, one, over and over and over again. And all of a sudden, you're spending a lot of wasted time pausing and spinning, right? And that becomes inefficient. Later on in this course, we're going to be talking about something called context switching. And context switching is that idea of pausing so that we can come back to it later. And it's extremely expensive. So one of the jobs of an operating system is to make decisions based on how do I best utilize the equipment attached to the computer, our resources, along with the user's requests. And sometimes that's not as clear-cut as we want it to be. And that's why we have to focus some on what the purpose of the operating system is. Are we making one person happy? Or are we making a lot of people happy? That's why often there's two different versions of operating systems. You have Windows 7 and you have Windows 7 Server, right? Windows 7 Server is going to be more focused on multi-user. Typically it's running as a web server or something else that's going to have multiple different external connections requesting the operating system to do something, as opposed to Windows 7 standalone is expecting just a dude sitting on the other side of the computer. That doesn't mean you can't run servers on Windows 7, but it's not optimized for multiple users. The operating system is a control program, controls execution of programs to prevent errors and improper use of the computer. Okay, so Amongst other things, not only is it fulfilling your requests, it also needs to make sure it fulfills them correctly, right? Now, because operating systems are so perfect, that's why none of us have ever seen a blue screen of death. Or if you're on an older Macintosh, the little original Mac unhappy face, the frowny face, right? See, Macs always, they crashed with style. You'd have the unhappy face, the machine was still on, and the mouse still worked. The rest of the machine was dead in the water. At least Microsoft gave you a blue screen of death with just random crap on the screen. I mean, if you're going to die right.
What was the little bomb?
Oh, a little bomb, I think, was a hard drive failure. Yeah, that was always good, like a disk crash. I didn't really think that out that well. I tell a story. My first, I guess, real computer was made by a company that doesn't make computers anymore called Epson. I think they make print. I don't even know if they still make printers. Does Epson still exist?
They still make projectors.
They make projectors? Okay. Well, they made my computer. So I had an x86 Epson computer way back when, and I used to write software on this thing. I started programming when I was 9, so I had that computer at least when I was 9. And one day I was using it when this computer crashed. No graphics, this was well before graphic user interfaces, so I was using DOS 1 or something like that. And the day the computer died, immediately preceding it, the computer literally made this noise. It goes, but it was like a programmed noise. And that computer never ran again. That's got to be some like engineer's joke. Okay, hard drive stop, heat sink, yeah. In any case, so the operating system has many jobs. There is no universally accepted definition of operating systems because we're inventing new ways every single day of utilizing computers. So the idea of a piece of software that sits between the user and the hardware changes constantly. I might argue that there is a universally accepted definition of operating systems from the perspective of it is a piece of software that lives between the hardware and the user / users. I think that's a fair statement. Okay, now I'm going to start disagreeing with some of these things. Everything a vendor ships when you order an operating system is good approximation, but varies widely. So, here, I'll read this last thing just in case it... well, here, we'll come back to that in a second. So, name some operating systems you're familiar with. Windows. Which Windows?
Windows 7.
Windows 7?
3.1.
Windows 3.1? Windows 95? Windows 98? Blah, 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 blah. Okay. What other operating systems? Mac OS? What about Linux? Linux operating system? What about Unix? Anything else? How many operating systems do we just list? 0. We've not listed an operating system yet. We've listed what are called distributions. Windows is a distribution of an operating system plus application programs. The actual operating system at the center of it is generically called a kernel. Generically. But that's the actual operating system. The core piece of software there. All that stuff that we see, even the visual side of Windows. The visual side of Windows, the actual windowing interface, is an application program. How many of you are Linux users? Okay, one person? How long have you been using it? Long enough that you had to configure your own graphic user interface, or did it always install with it?
No, I just use command line. I don't even use graphics.
Okay. Well, in the early days of Linux, when you first installed it, it only had command line. Then, if you wanted to have a windowing interface, you had to choose the windowing interface you wanted. You know, there was a whole bunch of application programs you can download that gave you the experience that you were interested in. One was called GNOME. That was a pretty popular one, GNOME. But in any case, then when you wanted to start that program, you boot it up into the Linux kernel, that's the actual operating system, the Linux kernel. And then you would say start X, and that would start the X windowing system, with the correct graphics and crap like that. So for Linux, the actual operating system is called the Linux kernel. What about Windows? What's the actual operating system called? Huh?
DOS.
DOS? Okay. I'm actually going to add a slide here. It's an appropriate. Do I get a blank one? This guy? There we go. So we have the Linux kernel. We have DOS. What does DOS stand for? Disk operating system. Who made DOS? Oh, no, that's not the right. Who made DOS?
Is it the government?
Not the government.
It's the same last name as the Twilight actor.
Well, the first people to sell DOS was Microsoft. And Microsoft made, or at least modified heavily, many of the older, or the newer versions of DOS. But DOS 1.0, the original DOS, was sold by Microsoft, but was made by somebody else. It's actually a fairly famous story. I usually say in a couple classes, you guys may have heard this before, but it kind of bothers me that you didn't know who was involved in DOS. Just idiots. What was I talking about? Oh, Microsoft. So, what is Microsoft most famous for? Microsoft really changed the computing industry in a very specific way. So if you had to give Microsoft credit for how they changed the software industry or the computing industry, what would you say?
They made everything standard.
Okay, that's a fair response. Not necessarily the one I was looking for, but certainly because of their popularity, because of the number of people that adopted Microsoft products, standards rose to the top, right? Before Microsoft, the big kid was IBM. Okay, even today, IBM's still a big company, and IBM makes hardware. Okay, so IBM makes their money off making hardware. Even today, IBM still makes servers, still makes mainframe computers, expensive, high-powered hardware that other people's software runs on. That makes sense? They're Intel powered, whatever, blah, blah, blah. Now, what Microsoft did to change the climate of computing is they brought into play the idea of licensing software. Probably, or at least arguably, the most profitable meeting in history was based around a lie. So we've all heard of Bill Gates, right? Microsoft dude. So it was Bill Gates, Ballmer, who recently stepped down as CEO of Microsoft, and who was the last guy? He's no longer on Microsoft's board. He's the dude who's deals with, he's one of the space race people. It'll come to me at some point. Third player, big rich Microsoft dude, one of the original founders. But now he's in one of those groups that are doing, personal space flights. The personal shuttles are taking people up into space, that kind of crap. But in any case, these guys sat at a table with the bigwigs at IBM. And IBM, so this is kind of when desktop computers were starting to become a reality. So after the transistor was announced, but before everybody and their brother had a desktop. So this is still when they're very expensive, but at least the reality of having a computer existed. And mostly it was nerd type stuff where you had kits. So you go out to a place and you buy the computer kit and put together your computer. Okay, make sense? Well, they're sitting there in this meeting and they said, so Microsoft, they're like, by the way, you guys have this hardware, you want to get into this thing, you're going to need our operating system to run on your computer. And why do they need an operating system? So that users can more easily interact with the hardware, right? And IBM says, okay, well, and then Bill Gates goes, but we don't want to sell you our operating system. We want to license it to you on a per machine basis. And what did IBM say as response? These are all true statements. This 2-minute little exchange might be the most profitable deal in history. IBM says, no problem. The real money's in the hardware. Now, what makes this even funnier, they closed the deal, shook hands, blah, blah, blah. Microsoft was going to make X amount of dollars per license of their operating system that goes on to the IBM machines. And then they went and made deals with a bunch of other places to do the same stuff. Problem is that when they made this deal with IBM, Microsoft did not have an operating system. They literally sold a lie to IBM. So now Microsoft has to go out and find an operating system. They bought DOS, the original DOS, from a computer shop nerd guy who, this was his hobby. He wrote an operating system as a side little thing. He ran a computer shop, sold computer components and stuff like that. But his hobby, in his spare time, wrote an operating system. A little crappy one. So Microsoft goes in there, wants to buy his operating system. Offers him $50,000. Now, you're a dude running a small-time computer component shop when computers are not popular. You're such a nerd that you write software for fun instead of going out with friends and stuff. And somebody comes in and offers you $50,000 for your software. What do you do? What do you say?
Yeah.
You say yes. Well, now Microsoft can complete their promise to IBM. They have an operating system. Do you think they made more than $50,000 on that DOS operating system? True story. Kind of an interesting background. So I'm going to stop right here. Remind me when we come back next time. I want to talk about kind of the lineage of the Microsoft side of operating systems. I want to kind of pause in the slide set and keep going down here. So somebody remind me kind of where I was in the world. All right. I will put up the Angel course is up. I will put up a link to the videos. Expect that you will have a homework assignment sometime this week. Might be next class, might be the class after that. Depends on kind of where we get. Questions, comments, concerns, bribes? Well, it depends. There's going to be a lot of programming. Okay, I'll see everybody on Wednesday.
All right.